Explain welding defects and its types. Sometimes the weld produced during the welding process may possess some flaws, such as slag inclusion, porosity, etc., which can hamper its usefulness. Such flaws are referred to as the welding defect. Thus, we can say that welding defect is the undesired irregularity present in the weld produced during the welding process. The different types of welding defects are undercuts, incomplete fusion, porosity, slag inclusion, and spatter. Undercuts refer to the unfilled grooves present along the edges of the weld. They mainly occur due to improper welding technique, excessive welding current, and incorrect manipulation of the electrode while depositing the weld bead. Undercuts can be avoided by using large electrodes and moderate currents by moving the weld torch slowly over the metal work pieces, and by placing the electrode at a safe distance from the interface of the work pieces. Incomplete fusion refers to the discontinuity in the weld zone. It mainly occurs due to improper penetration of the joint, wrong design of the joint, and by incorporating incorrect welding technique. Incomplete fusion can be avoided by supplying low electric current than required, and by cleaning the joint properly. Porosity refers to the cavities or pores caused due to entrapped gases in the molten metal during the solidification process. It mainly occurs due to contaminated gases in the molten metal. Inadequate shielding, unstable arc, small arc gap, and poor welding technique. Porosity can be avoided by proper selection of the electrodes and filler materials, and by decreasing the speed of the welding torch. Slag inclusion refers to the slag present in the welding product. Slag is formed due to the fluxes added during the preparation of the hot molten metal. It mainly occurs due to high viscosity of the weld metal, rapid solidification, and insufficient welding heat. Slag can be removed from the weld metal by grinding, wire brushing, and chipping. And spatter refers to the drops of metal expelled from the weld which sticks to the welding surface. It mainly occurs due to high welding current, long arc, incorrect polarity of the arc blow, and improper gas shielding. Spatter can be avoided by decreasing the welding current and arc length, by using arc having correct polarity, and by checking the correct shielding gas type and its flow rate. Related term is